We are doing this video today to cover section 4.3 that we talked about in class today. So we want to follow up, hoping to clear up any questions that we had. Remember that we started the day talking about congruent triangles. That if we have congruent triangles, that means that the three angles of one must have the same angle measure as the corresponding three angles in the other. Now, in other words, that tells us that angle A in the first triangle has to have the exact same measure as our A prime. Angle B in the first triangle has to have the exact same measure as B prime. And angle C in the first triangle has to have the same exact angle measure as C prime. Okay, remember that the order of the letters is very, very, very significant now. A matches A prime. So anywhere I put A in any type of congruence or equality, I need to match it with A prime from the other triangle. B is going to match with B prime. Everywhere I write B, if I write the corresponding angle from the other triangle, it has to correspond with B prime. And then finally, our C has to correspond to C prime. We can see that play out a little bit better when we're looking at the segments. Okay? When I look at segment AB, if I go from A to B, this segment right here, starting at A, going to B, that segment, then I must refer to the side in the second triangle as A prime, B prime, if I know the two triangles are congruent. And because of my congruency statement, I know my two triangles are congruent. When I go from B to C in the first triangle, that's going to correspond to this side that I duplicated in purple, and I would call this side B prime, C prime. And then on the bottom, if I say from A to C, and I call this AC, then I have to call the bottom A prime, C prime. What if I went the other direction? What if I went from C to A? Well, if I'm going to call the bottom CA, then I've got to refer to the base in the second triangle as C prime, A prime. And we did also talk about, and we saw play out in a proof, which we're going to do again in a minute, that it is important when we do a proof using congruent triangles, we have to have all 6 pieces of one triangle. That would be the 3 angles, the 3 sides. We have to have in the body of the proof that the 6 pieces in one triangle are congruent to their corresponding pieces in the second triangle. Okay, so let's keep that in mind, and then when we get to the proofs, we'll see that play out a little bit stronger. In conjunction with what we were just looking at, we'll look down here at these polygons or triangles that are not pretty side by side like that first slide that we had, or like the picture I had on the board today. These triangles are twisted around a little bit. Sometimes we're going to have them twisted around quite a bit. Sometimes we're going to have them overlap. Sometimes they'll share a side. Other times they won't share a side. Sometimes they'll share an angle, and other times they won't share an angle. But what we have to do is look at the corresponding parts and see if we can make a congruent statement, or if given a congruent statement, we can pull out the corresponding parts. Now, in this case, we have our drawing, and we have specific angles that match up with specific angles in a second triangle. So in other words, our A is marked to be congruent to H. So we are empowered to say they are congruent. Our B is marked to look like the J. They have one slash through them, so I know those two must be congruent to each other. And then finally, we have the C congruent to the K because of their markings. So I have all of those, or those two angles, congruent. Now let's see if our sides match up. Is going from A to B the same thing as going from H to J? Yes, it is. It goes from red to blue. Is going from our B to C the same as going from J to K? Yep, it's from blue to green. And is AC, going from A to C, the same thing as going from H to K? Yeah, it's from red to green. So everything corresponds. So we can write our congruent statement that triangle ABC is congruent to triangle HJK in that order. I could have put triangle BCA is congruent to JKH. That would be another valid statement. I could put CAB congruent to KHJ. As long as everywhere I have an A, the H is in that position. Everywhere I have a C, the K is in that position. And everywhere I have a B, the J corresponds. Over here we have a non-valid statement. ABC does not match HKJ. See, these need to be turned around because B does not correspond to K. It corresponds to J. So that's a no-no. We don't do that. Now, as we look at example 2, we'll make it a little bit bigger for us to see. Let's look how knowing what my corresponding parts are, and that means I'm looking at this. Knowing what matches what allows me to find some missing measures. So I know that A matches with D because they're mentioned first in the correspondence. Congruent statement, sorry. And then my B up here, I know corresponds to F. And then angle C over here is going to correspond to E. Not because of the way it's drawn, but because of the way it's stated in the congruent statement. Now I can do the legwork that they've asked me to do. I can set F, which is 8y minus 5, equal to 99, because I know that B and F are the same. And solving, I can find out what y is. If I successfully solve for y, then I'm going to plug that value in down here for y. And I see that I can now solve for x by setting my FE side equal to my BC side. Never, ever, 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 ever make the mistake of setting a side measure equal to an angle measure. Okay, that's one of those things that I call the black cloud. There's the lightning. Do not set an angle measure equal to a side measure just cause. Okay? There will be times when by coincidence maybe they turn out to be the same, but that will be just totally by coincidence. We will never depend on one to get the other. All right, now let's look at guided practice 2. I suggested in class that you may want to redraw those triangles so that they have the same orientation, like the one that we did on the board, the one on the first slide, and then the ones up here have the same orientation. So if you want to redraw, that's perfectly 100% wonderful. If you want to color code your parts so that you know what part goes to what part, that's absolutely wonderful as well. Now, I don't use my highlighter very much, so I don't know if I'm going to be able to do this very well or not. Give me a... Let's learn and see. Okay, I know that R and T match up. So I'm going to have... I didn't think I had my laser on. R and T are the same. Then I have S and V. So S is, let's use another color. S is this right triangle. So in the other triangle, V is right there. Those match up. That means that the leftover angle, the 78 right there, is the same as this piece of angle right in there. Okay, so if that little piece of V is 78 in the left triangle, it's going to be 78 in the right triangle, the matching position. Okay, we have to find the value of X and Y. I think we can find X right now. When I look in this triangle, remember our rule that if we have a right triangle, and we do, the two acute angles have to be complementary. That means they add up to 90, which makes sense because the two of those angles plus the other 90 degrees gives us the 180 degrees for the entire triangle. So since the two acute angles must be complementary, that means the 78 and the X has to add up to 90. Subtracting my 78, that means X is going to have a value of 12 degrees. So that means this little angle, this little sliver of an angle right there is 12. Even though they're not asking me for R, it's going to be 12 as well. It's the sides that can throw us sometimes. So let's look at the sides. I've got R to S. See if I can find another light color. I'll go with pink and see how that does. So from R to S matches from T to V. So that means my 2y minus 1 is the 24 side. And now we can just solve. I may, on some problems, have to take that further and look at where the SV and the VS come together, you know, and see different sides like that. But in this particular case, the RS was the one we had to find, so it worked out pretty nicely. So our X is 12 and our Y is 12 and a half. And we don't get upset if it doesn't come out even. Get a little drink of my Coke. Sorry, I felt the cough coming. All right, let's move on. This theorem, I ask you to read in class out loud to make sure it makes sense to you. And you said that it did, but let's talk through it again. Since all triangles add up to 180 degrees, okay, if two triangles in one triangle are congruent or equal measures with two triangles or two angles in the second triangle, let me write that out because my tongue got a little twisted there. So I've got the measure of angle A plus the measure of angle B plus the measure of angle C has to equal 180 because there's 180 degrees in a triangle. Then I've got the measure of angle L plus the measure of angle J plus the measure of angle K equals 180. If these two are equal, and these two are equal, and my sums are equal, doesn't it stand to reason that the third angles have to be equal, which is what they've named this particular theorem, the third angles theorem. If two angles in one triangle, which in our case are C and B, are congruent to two angles of the other triangle, which would be K and J, then the third angles are going to be congruent as well. So we're going to use that in a lot of proofs coming up. Speaking of which, here we go. Now remember back when we were on the first slide, I suggested to you that in the body of the proof, in the statements and reasons, we have to have each of the 6 pieces of one triangle, I'll just call this one number 1, congruent to the 6 corresponding pieces in the second triangle. That's how we show that two triangles are congruent. Well, they've given us a bunch of information, so they've made it a lot easier for us than they could have made it. So let's see what they've done for us. Let's see if we can understand this better. All right, they tell me that DE and GE are congruent. So that's one piece of the first triangle congruent to one piece of the second triangle. And that's the matching pieces. Okay, the DE and the GE. They also tell us that the DF, from D to F, and G to F are congruent. So that's the second piece of one triangle congruent to the second piece of the second triangle. The third sides they share, they have in common. I think I even mentioned to one class today that my geometry teacher, instead of saying reflexive, would have us say common because it shares the side. EF is congruent to EF. The EF in triangle 1 is congruent to the EF in triangle 2 because it's the same segment. And anything that's the same is equal to itself. So I have the third piece of the first triangle congruent to the third piece of the second triangle. So that's 3 of the 6 pieces allotted for by using the given and the reflexive. Now let's see what else we have. We are given that angle D and angle G are congruent. Okay, that's angle 1. So that's a fourth piece, congruent to a fourth piece. We're given that DFE and GFE are congruent. That's these little guys down here. They're congruent to each other. So that's the fifth piece congruent to the fifth piece. Now we have to somehow get these two angles congruent because those are the last of the 6 pieces of the triangle that we have left. Well, luckily in step 3 we're given that 2 angles of one triangle are congruent to 2 angles of the other. So we just learned that fantastic theorem, remember? We just learned that, come on now, by the third angles theorem, that the last two angles have to be equal to each other. So that allowed us to get the 6th piece of the triangle congruent. So I have all 6 pieces of triangle 1 congruent, and I'm able to validate why it's congruent to its corresponding parts in triangle 2. So once I have all of those 6 allotted for, then I can say my proof statement is true. Those 2 triangles are the same shape and size by the definition of congruent polygons. Since we're going to be using triangles, I do not mind at all if you say definition of congruent triangles. Okay, let's take a moment, if you want to stop the video and look at the guided practice number 4. We did it in a couple of the classes. I think one of the classes we didn't get to it, but we're going to do it now. If you want to stop it and re-practice it and see if you can do that one by yourself, that's great. Or if you haven't tried it yet, this is a great place to stop the video for a few minutes and see if you could do this proof by yourself. Okay, let's make our statements and reasons and see how we can work this proof. Bring it over here to the side a little bit. All right, we have angle J congruent to angle P. So let's focus on our angles here. Angle J is congruent to angle P. That's given. Okay, I'm going to hold off on my sides of my given. Let's see what else we can come up with. We got J congruent to P. I'm supposed to get the 2 at L congruent. I'll name those 1 and 2. I hope you remember that we can get angle 1 congruent to angle 2 because they're vertical angles, so they're congruent. So now I've got 2 pieces of the first triangle congruent to 2 pieces of the other. They both happen to be angles. Now I've got those 2 angles of one congruent to 2 angles of the other. So I know now that angle K is congruent to angle M by that third angle theorem we just learned. Back up on the previous page. Yeah, I think it's on the previous page. It may be at the top of this one, but previous page. So we've got all of our angles accounted for. All 3 angles of one with its partner in the other. Now we have to come up with our partners for the sides. I'm going to change colors for the side just for a learning process to make sure that we're okay. Okay, so I've got JK congruent to PM given, and I've got JL congruent to PL. That's given. I just split those up this time. I did not have to. I just chose to for variety. So that buster and that buster are equal, and then that little rascal right there and that little rascal are equal. I see that I've got to get that other diagonal in there somehow equal, and if you look, you've got more information. You're either going to have more information in your given or more in your diagram. So I can say, since L is bisecting KM into pieces, I know bisect means equal pieces. So I can say that LK is congruent, and since I went from L to K, I have to go from L to M, because the order of the letters matters. And that's because I have a segment bisector. Okay, so do you see where I have 1, 2, 3, 4, 5, 6 parts equal to their 6 parts? So that means my 2 triangles are the same shape and size. No one can argue it. We've laid out an ironclad argument, and that reason is definition of congruent polygons. Again, you can say triangles if you want to, when it's specifically a triangle. Okay, you can stop if you need to copy that down or think about it. Let's look at some of the homework problems. The first one you had in your homework, show that polygons are congruent by identifying all congruent corresponding parts, then write the congruent statement. Okay, for number 2, this is the first one on your homework. What they're asking us to do is state that angle A is congruent. Now look over and see where it matches. Because of the way that the angles are marked, I know that angle A is congruent to angle E. I know that angle B is congruent to angle F. I know that angle C is congruent to angle G. Coming on around, I know that angle D is congruent to angle H. Now I have to do the sides. I know that from A to B equals E to F. I know that BC equals FG. I know that CD equals GH. And finally, DA equals HE. So we have, at this point, we have identified all the corresponding parts. Now, when I write my congruency statement, I can't do triangle this time because this is a quadrilateral. I'm going to say that poly means polygon. Poly ABCD is congruent to poly, make sure your letters are in order, EFGH. And that's what number 2 is asking you to do. Let's look at number 4 here. We have 4 through 8. Now, again, the order of the letters matters. So let's look at what we've got here. We're trying to find X. And I see in my first triangle that X is part of a side. Okay? And it's part of the side that goes from L to M. Okay? So Q to R should be my other side that matches. So to find X, I need to set those two congruent sides equal to each other. The algebra was easy, so X is going to be 20 for number 4. For number 5, we have to find Y, and Y is given in angle M. Angle M corresponds to R, so they've given us that as well. So to find Y, my Y plus 10 matches my 2Y minus 40. So Y is 50 for number 5. Number 6, let's see if I need to move that over. No. Number 6, because of the markings, I can see what angle matches what angle, which will help me, of course, do the sides as well. So I see that B matches H because of the marks, and I see that A and F are both right angles. So that means C and G are left by the third angle theorem to be the two that are equal. So my X is 40 for number 6. Number 7, I see that my L matches the Z. I see that M matches the Y. So my X, which is an angle of 4X, matches N. I don't have any information for N, but I can sure find it. Since there's 180 degrees in this triangle, then 65 plus 51 is 116 that I need to take away from 180 to have that N is 64 degrees. So I know that my 4X is 64 degrees. X is 124/16. Okay. Shall we look at the proof now? It tells me low battery, but I've got my iPad plugged in. So let's see if we can get through the proof. Alrighty. All right. The given, we got a lot of info in that given. WXZ WXZ, that's that guy, is congruent to YXZ, that's that guy. Okay? We're also told that XZW, that's that guy, is congruent to angle XZY. That's that guy. I don't know why I personify these angles. Okay, so I've got those two angles equal. That's given. Let's clean up the angles now. Can't you see that, or I hope you can see that? I can say that W is congruent to Y because of the third angle theorem. I have two angles of one congruent to two angles of the other, so the thirds have to be equal. So that took care of my angles. Let's go on and look at the sides now. They tell me that WX is congruent to YX. WX, YX. And WZ is congruent to YZ. WZ and YZ. So that's given. Now, it's that third side I've got to come up with that's the same in the left and the right because I have to document it in my proof. And that's that shared or common side again. So XZ in the left triangle is congruent to XZ in the right because of reflexive. Now I've got all 6 pieces of the left congruent to all 6 pieces of the right. Therefore, my triangles are equal. Make sure you get the letters in the right order. And that's the definition of congruent polygons. All angles are equal. All side lengths are equal. And I should put that part corresponding. Corresponding is very significant. All right. I hope those are getting easier for you. I really do. Now let's look at this monstrosity we have down here. Let's see what matches what. Okay. All right, let's see. I'm going to mark the congruent pieces first. B matches R. C matches S. D matches T. Let's bring another color in here. E matches U. Okay, so now I can see not only my angles but my sides if I'm careful. So I'm looking for X, and I see that X is mentioned in angle B here. So I have 2X plus 9. Now let's look in the other triangle, or the other, this time quadrilateral, or actually this is a trapezoid. B matches R. R is 49. So 2X is 40, or X is 20. Okay, we were able to handle that. Now let's look at the Y. Where do I see a Y? I see a Y at D. Angle D is 2Y minus 31. Now let's look over. D's matching T. T up there is Y plus 11, so those have to be equal. So Y equals 42. Okay, 15, I'm looking for Z. Now I'm shifted over to segments. So from E to D is 3Z plus 10. So that's from red to green. So from red to green up here is Z plus 16. So 2Z is 6. Sorry, that should be a Z. Z equals 3. And you can plug back in and check them. Then for my W, W is up here at BC. So that's 4W minus 7 equals 2W plus 13. So 2W equals 20, or W is 10. It's perfectly okay to color code. You can use highlighters. You can use color pencils, markers. I think color pencils are usually neater because the markers can bleed through your paper. But if you're careful and neat, it's not going to be that big a deal. Okay, so you can do that on test quizzes, whatever. I'm perfectly fine with it. right, let's see. I don't think I gave you anything on this page. Let me double check. No, the next problem is 28. So let's go over. 28. Draw and label a figure to represent the congruent triangles. Then find X and W. Okay, I'm going to make this a little bit smaller so that I can do the work over to the side. So on 28, I need a triangle ABC, and I'm going to draw them just as simple and reasonable as I can. If they are off scale, I don't care, okay? I'm following the math. Okay, so ABC corresponds to DEF. So I know that I've got everything marked accurately. Now, AB is 7. Let me change color on that. AB is 7. BC is 9. AC is 11 plus X. DF is 3X minus 13, or minus 13, sorry. That looks too much like a plus sign. Let me make it better. DF is 3X minus 13, and then DE is 2Y minus 5. We're supposed to find X and Y. So once I have them drawn like this, it's easy to see what matches what. AC matches DF, so to find X, I can just say 11 plus X equals 3X minus 13. 2X is 24, X is 12. Then to find my Y, notice that your Y side matches a value that's been given. So Y is 7. That one was fun. Okay, let's look at 30. Same kind of thing. Again, don't get bogged down with having to draw them on scale. We don't care about that. The math is going to hold true if we do the math correctly. So on number 30, I've got triangle JKL congruent to MNP. JK is 12. LJ is 5. PM, down here at the bottom, is 2X minus 3. Angle L is 67. Angle K is Y plus 4 degrees. And angle N is 2Y minus 15. I'm just going to put that up here. And we have to find X and Y. To find X, do you see our bottoms there? They correspond. So 2X minus 3 equals 5. 2X is 8. X is 4. Then this time my Y's are angles. Never set angles equal to sides. Never set sides equal to angles. These are both angles. The Y plus 4 equals the 2Y minus 15. So Y equals 19. Okay, we've about got this assignment whipped. We still need to do number 39 on the next page. Okay, it tells us we have a challenge. Let's see if it is or not. Let's see if we can beat it. Okay, find X and Y if PQS is congruent to RQS. I'm going to mark those. Okay, P corresponds to R. Q corresponds to Q. And guess what? S corresponds to S. So that means we've got 2 right angles in there. Okay, now we've got to find the X and the Y. I see a system of equations. Do you? I see that X equals 2Y because this equals this. And I see here that 2X equals 3Y plus 8. Of all the ways we have to do a system, the way that this information is set up, it looks to me like substitution is going to be the easiest way. Not the only way, but the easiest. So I'm going to take what X is equal to and plug it in. So instead of 2 times X, I'm going to say 2 times 2Y. So 4Y equals 3Y. Y equals 8, so we've got half of it taken care of. So if x is 2 times y from my system, then that means that x is 2 times 8, or 16. So x is 16, y is 8. That wasn't as much of a challenge as you would think it would be when you first look at it. So another reason to not run away from the challenge ones, usually they're not nearly as difficult as we're afraid they're going to be. All right, that finishes up 4-3, and we'll look at 4-4 and 4-5 together as we do further proofs with proving triangles congruent.